sample question 7 here says, how much energy is dissipated by the 5 ohm resistor in 120 seconds? So they have given us the arrangement and they're asking us how much energy is dissipated by the 5 ohm resistor in 120 seconds. So how do you calculate the this is related with the electricity and the voltage register and the other stuffs, current and so on. Now how do I calculate it? So like the amount of energy dissipated in this one, we calculate it by finding the what is the current flowing through it, individual register, and also we need to calculate it by using the concept called Ohm's law. You might be studied in a school what the Ohm's law says. Ohm's law. So what the Ohm's law says? The Ohm's law says that the voltage applied across a terminal or the voltage applied across a circuit is equal to the product of the resistor of that circuit times the current flowing through it. So that's simple. I can say V is equals to I times R. So voltage is equals to current times the resistor. Resistor is this is symbolically we represent. Now look what happening here. The register arrangement are given here is in which type of arrangement we say. I can arrange the registers in two ways. One is called the series arrangement and another one is called the parallel arrangement. So what actually the series arrangement is, let me show you. If the registers are connected end to end, this is the register R1 if I say, and if I'm connecting this register R1 with the another register called R2, another register called R2, this kind of arrangement is called the series registers. I can connect as many registers I want. So this I can connect further with another register called R3. This kind of arrangement is called the series register connection, series arrangement. And when the registers are arranged in series, to calculate what is the total resistance of this all arrangement, what is we say the total resistance or the effective resistance when they are connected in series. The effective resistance is basically the sum of the individual. So total resistance in series Rs, I can say the total resistance in series Rs can be written as R1 plus R2 plus R3. Simple. So this is how you calculate the resistors when they are connected in series. But what are the other concepts we need to know? This information is not related to the question, but I am explaining for the better understanding. We don't know in exam we're gonna get the question in the same way. So they may ask you, rather than giving the parallel, they may ask you for the series resistance or all. So better to know, right? Of course there are like a lot more things to be studied, but I'm solving questions relevant and I'm providing the relevant information related to the questions given here. So what other things I need to know when the registers are connected in series is, when the registers are connected in series, suppose you are applying a voltage with the certain volt, usually we say a battery, and because this arrangement a current will flow in the circuit, and always we know that the direction of the current is from the positive towards the negative, something like this is the amount of current flowing through. Now how do you calculate the what is the voltage or the current flowing through? One important thing I want to mention here, when the registers are connected in the series, the current flowing through all the register, it's going to be the same. The current flowing through all the register, it's going to be same. So suppose if the current, assume if I'm taking the current here as 2 amp, the current flowing through this register is also going to be 2 amp. Here is also 2 amp, here is also 2 ampere, and so on. The current is going to be the same when the registers are connected in series, but the voltage across the each register component is different. If current is same, the resistor is different, so the voltage across this one is going to be different. So voltage across this component, I may write it as V1. Voltage across this component, I may write it as V2, and the voltage across this component is called V3. So voltages are different and the currents are same. Current is same when the series arrangement. Okay, so this is the important point need to know when we are working with the resistor voltage and the current arrangement. So now come back to our question here. They are asking us what is the energy dissipated in the 5 ohm resistor. They are asking us what is the energy dissipated here. So what is the energy dissipated in this 5 ohm resistor? So first, before calculating the energy, let me show you what is the energy dissipated formula. E is equals to the voltage times the current times the time. The product of the voltage current times the time. So product of the voltage and current, it's basically the power. Energy can also be written as power times the time, and the power of the circuit, it's gonna be the voltage multiplied by the current. So this is just like, the different formulas. So I can make use to calculate the energy dissipated here. I know the voltage, it's a 20 volt. I know the time they have given to us, it's 120 seconds, but I don't know the resistor. So how do you sorry, I don't know the current. How do you calculate the current? We can calculate the current by referring to the diagram. So before calculating it, I need to know what is the parallel arrangement of resistor concept is. Now look at here, the resistor, that is 5 ohm and the 6 ohm resistor, both of these two resistors are arranged in a parallel. So when the resistors are arranged in a parallel, when do I say the resistors are arranged in a parallel? If all the end of the resistors are connected at one point like this, and all the other end are connected to the another point. So this kind of arrangement is called the parallel arrangement, R1 and R2. Now how do I calculate what is the total resistor in parallel? What is the total resistance of this circuit? The total resistance when it has been connected in the parallel, we can write it as 1 by Rp is equals to 1 by R1 plus 1 by R2. This is the formula to calculate the total resistors which is connected in the parallel. So that's, we can say 1 by Rp is equals to 1 by R1 plus 1 by R2. So if we can modify further, what you're gonna get? 1 by Rp, just a mathematics, okay? To make a common denominator, do the cross multiplication and multiply with each other. This can be written as R2 plus R1 divided by R1 times R2. R1 times R2. So this is the value of your Rp, but I need to know the what is the value of effective parallel resistance. So effective parallel resistance, let me take it down here. The effective parallel resistance are, I can write it as Rp, can be written just by flipping it, right? So R1 times R2 by R1 plus R2. So this is how I can calculate. If you refer to the arrangement here, let me consider this is R1 and let me consider here R2. So I can calculate what is the effective resistance of this one. Is going to be Rp is equals to R1 5 times R2 is going to be 6 divided by 5 plus 6. So 30 divided by 11. So 30 divided by 11, what value we going to get it? Just check it out. So 30 divided by 11, that gives us the value here as 2.72. So this is going to be 2.72 ohm. So this is the value of resistor, 2.72 ohm. So this is the value of the resistor. So why I am finding the value of the resistor here is I need to calculate what is the current across the circuit. So how do I calculate what is the current across the circuit? See, when the resistors are connected in parallel, the current flowing across the circuit, it's going to, let's say, suppose the current I is flowing across the circuit here, but as the resistor has written in the parallel, connected in the parallel here, the component of the resistor current after coming over here, the current will get divided. So a part of the current flows like this and the part of the current flows like this. If I'm saying the current flowing through this branch, it's called I1. Current flowing through this branch is called I2, let's say. So the part of the current flowing through this, then how do I calculate what is the current flowing through this one? What is the current flowing through the R resistor R1 which we have mentioned? I can write it here as I1 is simple voltage across the resistor times the resistance, like the current is, according to that, current is equals to V by R. So what is the value of V? When the resistors are connected in parallel, the voltage across the entire element, that is the resistance, is same, but the currents get divided. Previously, when the resistors are connected in series, what happens? The current remains across each element same, but the voltage get divided. But it is in parallel, opposite. Current get divided through this each resistance, and the voltage remains the same through the parallel, because the terminal we have connected at the common point. So this is how you calculate what is the current across the 5 ohm resistor. So that can be written as 20 divided by 5, that's gonna be 4 ampere. I can, and this current I'm taking it as I1. I2 is the current across the 6 ohm resistor. So that's going to be V divided by, again, R, that is going to be 20 divided by 6. So what value we going to get? 20 divided by 6, that's going to be 3.33 ampere. So now look at, as the resistor value increases, the current flowing through it is decreases. So that's how the current and the resistors are inversely proportional. So this is what it shows. All right, so this is the value of a resistor. Now what is the total current flowing through the circuit? Total current is basically sum of this one plus this one. So why I am telling here is, sometime they just asking you about what is the energy or the power something, they may ask you about what is the total current flowing through the circuit. So total current here, it's going to be sum of the individual current, or I can also calculate in this way as well. So total current is basically the effective resistance. So I can represent this together, the parallel combination with the effective resistance, as this is going to be 20 volt with the effective resistance here as 2.72 and the 20 volt, if and the current is flowing in the circuit, I can calculate what is the current now. I is equals to V by R. So V is going to be 20 divided by 2.72. What value we going to get? 20 divided by 2.72. 20 divided by 2.72. We're going to get the answer as 7.35 approximately. So 7.35 amp. Same thing, if you add this 4 and 3, we are getting it as 7.337. When you add together the I1 plus I2, 7.33 amp. So this is the value, why we are getting some slight difference, because we haven't considered the all the digits which are till like repeating and repeating digits. So that's why it's a slight error, but you can do it in either way. So for this, for solving this question, whatever the second part which I have explained here, it is not necessary. It's not necessary, but because I'm just telling you, if the question is in the other way, if they are asking us to find what is the current across this one, so first you have to calculate the total resistance, that is the resistance in parallel, then you have to find the current across. But for this, to solve this question, this information is enough. To solve this information, individual information is enough. So I can calculate the current across the each register as we mentioned. I have mentioned for the understanding purpose this as I1 and the I2. So I1 I got it as 4 amp and I2 I got as 3.33, and together that gives you the value as what we got. So but I just need to use this here. So because I'm looking what is the energy dissipated in the 5 ohm resistor. So energy dissipated here is, as I said, voltage will be common across, and the current through the 5 ohm resistor, that's what we have taken it as I1, and the time. So let me write it here. So energy dissipated is equals to voltage is going to be 20 times the current is going to be 4 amp times the time, it's going to be 120. So just do the multiplication. 20 times 4, 20 times 4 times 120, you're going to get the answer here as 9600 joule. So energy is represented in the unit called joule. Which option is giving you 9600? Option A is 80 joule, B is just 4 joule, C is 1.2 times 10 to the power 4. It means it's talking about the 1200, like 12,000 basically. And D is 9.6 into 10 to the power 3. Yes, so D is the answer. So 9.6 into 10 to the power 3, it is same as 9.6 multiplied by 1000. So 9.6 multiplied by 1000, that gives you 9600. So 9600 joule can also be written in this way. So this is the right answer.